Okay, so in this session we will be discussing about the kind of software architecture these days, which is Microservices Architecture. Maybe some of you are familiar with this kind of architecture, so you decide to give your thought or your experience, anything about Microservices Architecture. Let's get started. I'd like to remind you about some years ago when we were building with this kind of architecture. So the first one would be the one-tier architecture. So everything starting from the UI and application, logics, and persistent layer are deployed in one machine. The example of this kind of architecture is like the classic macro-based application or Excel-based application, right? So you get a form, application logics, and database in one machine. And the next one is two-tier architecture. So we split between the persistent layer and the application and UI. So we get a smart desktop application that is accessing a centralized database server, right? We can install multiple client application, and we can have one single database server, and all of the data are stored in the one single server. Next up would be the three-tier architecture, right? So we get a UI, and in the middle of the UI and the database layer, we get an application. It can be a web services, or it can be MVC web application, right? And in another machine, we get a database server. So in this kind of architecture, we split all of the tiers. Right, so the example would be a simple web application like accessing a web server and accessing another database server. Or it could be a mobile application, right, which is accessing a web service, and the server will access a database in a separate machine. Right. So my question would be, what's wrong with this traditional architecture? Anybody can help me? What's wrong? Nothing wrong. Okay. That depends. Yeah, that depends if your use case is building a company profile or building a organization website. That's nothing wrong with this kind of thing. Okay, let's point it out. The first one, maybe you have experienced it. If your application gets bigger, right, it means that your code base will get bigger as well, right? And you can imagine if you would like to extend your application. Let's say that you are building a new features or finding a bug, maybe it would be very challenging, right? To deal with one giant code base and find bugs in one single code base. In software development lifecycle, we got a lot of feedback loops. For example, from developers to QA. After finishing a features or after finishing story, we ship the new features to QA, and QA will test it, right? And QA will give the developers feedbacks whether he or she find a bug or it is accepted, something like that. So this kind of feedback loops, if we deal with traditional kind of architecture, will get slower, right? Another feedback loop could be time to market, let's say. So if we have a traditional tier of architecture, if we want to launch new features, we need to deal with a giant code base. It means the feedback loop between feature 1 to feature 2, let's say, is a little bit longer. It is glued to one single technology stack. What I mean is, if you started building your application using, let's say, C# or Java, right? It means that in the next feature, and you are planning to build new features, new modules, you cannot run from your existing technology. Let's say, in the next 10 years, there is a, let's say Python gets a lot of attention and everybody will consider using it, right? And you are tempted to use it for your next module, you cannot do that. And the next one would be scalability limitation. So in this case, if your application gets a lot of traffic, a lot of demand, right? And the way to do a scale up of your application is to replicate the whole application, right? You cannot do a scaling in the module availability level, right? So you need to replicate, or you need to increase to the scale, increase the RAM, the processor or something like that. There is a limitation of the scalability. Okay, to give you a better understanding of the scalability limitation, I'll give you a case study. I'll pick online shop. Why? Because I know most of us like do online shopping, so it would be familiar with us from the use cases. Let's say we are building an online shop, a simple web application that contains 3 services. First one would be order service. It will maintain the transaction, the checkout procedure, something like that, and the customer service. Customer service will maintain things like customer registration and customer data. And next one would be reporting service. In the client side, we get a web application and we get a mobile application, and all of these client application will access directly to the website, right? And in another machine, we get a database server that is the repository of all of the data coming from the services. It's very simple. Okay. After running several years, let's say there is an investor named ABB Venture Capital, let's say, and this investor is very interested in our growth. That's why we get a lot of money, right? So we can purchase, let's say, we can purchase another web server, or we can purchase load balancer. Because we are rich, we can purchase 3 database servers, right? So this one is our first scaling strategy. So we split up the web server into 2 web servers, right? And in the middle of the 2 web servers, we got a load balancer that will handle the traffic. And for the persistence, we got 3 databases, so we can replicate, right? We use master-slave strategy. The first database would be the master one. So we do a lot of write preparation for this database, and for the next 2 would be the slave. You can use it for rate optimized operation. Okay. As you can saw that the demands only high on one services, which is the customer service. Why? Let's say because we give a lot of coupons, and the coupons will only be applicable to the new customers, right? So that's why most of our visitors will register themselves as a new customer, and that's why the demand to the customer service is skyrocketing, while the demand to the other service is just normal or just low. And my question would be, how do we keep our application performant? How do we keep our application strong enough to handle the request? Anybody can help me? Yeah, if you have a lot of money, you can replicate another, or you can scale another web server, but it doesn't solve the problem because you are spending too much money to do the replication. Right? Your needs are only on the customer service. Okay. Before jumping into the solution, let's go back to the very basic principle of building a new software. I know that you are already familiar with this tool, which is the loosely coupled and highway user, right? So building a good software needs to be loosely coupled and highway user. That is the basic principle. And to achieve that, in the architecture, we know the clean architecture. The clean architecture is the architecture that is designed for the inhabitants. The inhabitants, I mean, is the user, the software developer, and the creating who build the system, and the developer team who will maintain the system in the long run. Right? So a good clean architecture is designed from those things, not designed from architect or machine. It means that we cannot, let's say, sacrifice our design or our architecture for the sake of performance, sacrificing human readability. So our code is not human readable for the sake of performance. Okay, in the clean architecture, there is a new paradigm of seeing the software. Let's go back to high school science. I know that you remember this one. The way to look at the Earth as the center of the universe and Sun as the center of, let's say, a Milky Way galaxy or the universe. I don't know. We can correlate that into the way we look at the software layers or software architectures. I'm sure that we've been dealing with this kind of architecture. So we look at software from the database angle first. Let's say we are building a new software, we need to make sure that all of the database schemes are fixed and there will be no change for the structure of the database scheme. That's why we are confident enough to do the next level, which is wrapping up with ORM. And we build our class that will map one-to-one to our table. Let's say table A will contain X, Y, Z columns in our class. Class A will contain X, Y, Z property. So it will be mapped one-to-one. Right? After that, we wrap it in the services, can be application service or domain service, and on top of it, we have a UI. And if we do pivoting, we take a different angle to look at the software architecture, we can think differently. So instead of looking at database as a core of our application, why don't we put a lot of attention in the domain? I mean, domain is the area of the business that we are trying to solve. Something like in online shop, the domain is online shop. So we got a customer, we have the order, product, something like that, right? That is the domain of online shopping. And that by doing so, we will deal with a lot of design in how to map the real business case into our class, our domain class, something like that. Let's say we will train a customer that we have a lot of capabilities of being customer, something like purchase of product. After designing the class, the domain class, we write it in an application or business logic, and the database is just only the detail implementation of our application. We can just use an adapter that map from domain class to database class, right? So it means that in the next 10 years, maybe, if there will be a new sexy database technology, we can just reuse our domain class and build another adapter to that database. Okay. So by looking at that angle, we can say that actually the software architecture slices is not only the horizontal slice. I mean, I'm sure that we know what presentation layer is, what application logic is, and what the system layer is, right? That is the horizontal slice. But if we pivot it into the vertical one, we will be able to see that our application contains so many vertical slices. It can be order module, customer module, or reporting module. And all of the horizontal slices for each of them is up to them how to organize it. Let's go back to the case study. So maybe you are thinking, instead of slicing it horizontally, which requires me to do a scaling for the whole application, right? Why don't we do a scaling only for the vertical layers? It means that we will have this part of our system or the service separate from customer service and separate from reporting service, right? So in case the demand to customer services is skyrocketing, we're just scaling up the customer service. Just put a lot of VM or a lot of containers for the customer service. And we can say that because all of these are loosely coupled, so we can separate the database as well. Instead of dealing with a big giant scheme, right? A big giant constraint database for key blah blah blah. Why don't we just split? So we got an order database here, which is only focused on the use case in our services, and customer database, which is for the customer services, and we can use another technology of database, which is used by the reporting service, because we know that in reporting service there will be a lot of read-heavy operation, right? There is no write, update, delete operation in the reporting, right? Why don't we just change the technology? We can leverage it further. For example, because we know that the order service is separate from customer service and it is also separate from the reporting service, we can assign different teams. It means that they will have some degree of autonomy. Let's say we can say to our team, you can use technology stacks whatever you want. For example, in Microservices you can use .NET, maybe. In customer service you can use Java, and reporting you can use Python. Just use technology that is optimized for your business process. It means also that they will have different life cycle, right? Let's say at the moment the Microservices is version 1.1, and let's say in the customer service version 1.2. So they will have this kind of capability. They will also have domain expertise. So for customer service team, they don't need to know the business process of the other services. They just focus on the customer. Okay, this is the short summary. If we look at software architecture as a food, the bread architecture is something like, pancit mie Jakarta maybe. The spaghetti code, it is very difficult to track between one part to another part. Traditional three-tier architecture is like lapis legit Surabaya. So yeah, it contains several layers. For Microservices architecture is just like a bakso Malang. Because I'm from Malang, I'm very proud of it. In bakso, we know that it contains like pentol, right, or tofu, or noodle, or something like that. And all of these things are functional. You can eat pentol separately from tofu. But if you combine all of these items, you will get harmony, right? You can get a bakso flavor because of eating all of these things, right? You can say that Microservices architecture is similar to bakso. Let's move on to the how, right? If we have a monolith or we are planning to build a new application, how to build the monolith application? This is the very popular approach of building an architecture. Maybe most of you think that why don't we just start with building microservices from scratch? Well, most of the experts say that if you start building your application by using microservices paradigm, you will be more likely to fail. It is difficult for you to see the process boundaries. It is difficult for you to see this part belongs to this module and this part will belong to this module, right? That's why the most recommended approach to build a microservices, you start with monolith. So just build a monolithic architecture first, right? And by doing iterative development, you will consider this part will be module A, this part will be module B. You can organize it accordingly, something like this. This one is, it's mixed. So and this one is organized, and you can see the process boundaries here. And once you are confident to split your part of application, you can split it as an independent system here. So this is the independent system of your module, which is coming from the monolithic. And by the end of your journey, you will have multiple microservices. This is also known with this name, Strangler Pattern, right? So Strangler is the name of the giant tree in Queensland, by the way. So the way it produces another tree is it splits its root into another tree, and the other tree will grow. Doing the migration to microservices or the modern kind of architecture is something like this. You build a facade. Facade is just like a bridge application or bridge application that will facilitate the communication between the legacy and the new one. You can do gradually, so you migrate the traditional to modern, and by the end of the migration, you will have all of the things in the modern architecture. Microservices is a new way of doing software development. There are also a lot of enabling technologies, so I can say. The first one, I think you are familiar with this automation tools. Can be CI/CD, can be Jenkins, MCP, can be CI, or Go Continuous Delivery, or Visual Studio Online. Yeah, I'm sure you're familiar with it, so I can move Next one. Next one would be virtualization, right? Remember that each of our services is separate in the different machines, right? We need to provide an infrastructure that virtualize that machine. It can be a virtual machine, VM, the traditional VM. You can use VMware, Hyper-V, or VirtualBox, whatever. So each of your services will be deployed in the different VM, or the newer one is the container. The difference between the VM and container is in VM, you also store your operating system into your image. It means that it will have a bigger size because you need to store the OS as well. But in container, you can just focus on the application and its dependencies. For example, if I have a .NET application, I can store my .NET application and all of the DLLs, or Java application, I can store my Java application and the Java files. Yeah, the dependencies and the application itself. So it means that you can use the shared kernel of the OS. And of course, it will affect the size of the image. And after wrapping each services in different container or VM, you can use this guy, the orchestrator, right? So remember that you need to do a harmonization of your services, right? How to do that? You need to put all of your containers into a cluster. We call it a cluster. A cluster is an isolated environment that contains a lot of nodes, which is container or VM. So this guy will be responsible to do a health checking as well, and will maintain the way to communicate between different services. The example will be Apache Mesos, or in Microsoft technology, you can use Azure Service Fabric, Kubernetes by Google, and Docker Swarm. Next up would be message broker. Because you deal with the distributed computing, right? It means that you need to enable services to communicate with each other. You can do it synchronously. It means that since service A will request to service B and wait until service B responds to service A, it is synchronous. Or you can do asynchronously. You just throw an event or comment to something, right? Which is message broker here. And message broker will handle all of the publish subscribe paper. So things like RabbitMQ or Apache Kafka, Microsoft Azure Service Plus Q will handle all of these things for you. Next one would be centralized monitoring tools. Remember, because we separate all of our services, it means that we need to delegate the monitoring tool, the logging process into one dedicated service, right? One dedicated part. It means that this guy, the central monitoring tool, will monitor all of the services in your cluster, in your environment, and it also do a health check as well, and it will maintain the performance of your services. The example of this centralized monitoring tool can be New Relic, Stackify, Azure App Insight, or Nagios. Let's talk about the trade-off. So before deciding whether or not you are moving your application to microservices, let's consider the trade-off first. Let's highlight the pros. Of course, the scalability, right? Based on our case study, it's obvious that we will have a lot of flexibility to do a scaling for our application if we implement microservices. Next up would be resilience, because we have orchestrator and we have central monitoring tools. It means that in case we have a service which cannot be accessed or cannot be used by another service, this guy, the orchestrator or the centralized monitoring tool, will send a notification to you. You can configure it to send an email or something like that, right? And the orchestrator will have an ability to replace into another VM, something like that. Or you can do a degrading functionality. So you got two versions of services. Let's say on the service version A is the full-blown services. You have a lot of capabilities of the service. But if these services cannot be accessed, you can change by light version of the services. Right? So you degrade the functionality of the service, but it is still functional. Right? So it means that your application will be more robust, right? In monolithic application, if one service is not accessible, the whole application cannot be accessed, right? If you are using microservices in one microservice cannot be accessed, the orchestrator will react and replace it with another instance or another great function. Next one will be from business case, business point of view. So you know that you can split your team based on the vertical slices, right? So it means that you can better align your organization with your software architecture. There will be minimal developers or minimal people dealing with one code base. So you will be easier to onboard your new staff, or you can make your new staff confident to learn something because it is not complete. And of course, I need to mention about the heterogeneity. Because we have independent services, it means that it is possible for us to experiment with the new hype. Let's say that, wow, I want to experiment with Cassandra, let's say. I want to experiment with Cosmos DB, let's say. You can just build another service, right? And once it is ready, just migrate the other service to access the new service. And we can also say that these services can be built by using Python. These services can be built by using .NET. It's up to you guys. You can do that. How about the cost? The cost of microservices. First, of course, it is the cost, right? Because you need to provide things like container and orchestrator and whatever. Centralized monitoring tool. All of those things, of course, are not free. Right? You need to provide an upfront cost. But many experts believe if you are running, stable application and you are, extending your features, the cost will be flat compared to the monolithic one. In monolithic, the way to scale up, remember, you need to scale the whole application, right? But in microservices, you just pick which services which is very basic, which is high demanding, and then you just scale that services. Next would be the distributed system. To build an application that can be deployed in the distributed system is challenging, right? It's daunting. So you will build things like concurrency, race condition, or remote call procedure. So this of failure as well. And because of the distributed computing, it will come what is called eventual consistency, right? Because you have a distributed database or repository, you will need some delays to update all of your application, all of your part of your application, right? So the delays can vary. It can be in terms of milliseconds, it can be in terms of seconds or minutes. It depends on how good you are building the software. Next one will be operational complexity. Yeah, because this is the new paradigm of building a software. You need your team to learn new skill and new culture. There are a lot of new methodology to build microservices, but the most well-known one is the 12-factor 12-app methodology. It is popularized by Heroku. You need your team to learn all of these cultures, new skills. Okay guys, if you want to learn deeper about microservices, I highly recommend you reading this book. The first is Domain-Driven Design. It will give you a lot of insight about how we can build an application that reflects a business case. Right? It will give you insight how we can create an entity, how we can create a value object, a repository, a domain event, things like that. You will be very knowledgeable about the basic things. After that, you can move on to the next one, which is the implementation. pattern principle and practice of domain-driven design. You can implement the concept of domain-driven design in your favorite technology, Java, C#, whatever you can name it. And so, and after that you can move to microservices. Because if you go directly into building microservices, there are a lot of jargon. And you need to go back to what this jargon means. Right? So it will be not convenient for you. I think that's pretty much it. Then I'll try to deliver. Maybe the next one is Q&A session.